Target 6.2. I can use the solubility rules to determine if a compound is soluble in water, and use symbols to indicate the state of each substance in a chemical equation. First, we will concentrate on just using symbols to indicate the state. When a substance is a gas, we denote that with a lowercase g in parentheses. Liquid, we use L. Solid, we use S. Aqueous, we use AQ in parentheses. Aqueous means dissolved in water, or sometimes that's called a solution, like a sodium chloride solution would be AQ. All acids are aqueous. So, for the following, chlorine gas, we would indicate that with a Cl, and since chlorine is diatomic, we want a 2 there. It tells you that it's a gas, so we will indicate that with a lowercase g. Water would just simply be H2O, L for liquid. Steam would be H2O, G for gas. Ice would be H2O, S for solid. Solid sodium chloride is just NaCl, S. Sodium chloride dissolved in water would be NaCl, AQ. Bromine. For elements, you need to look at the periodic table. The color coding will tell you the state. If you don't have the periodic table with color coding, you can always look these up online. Remember that bromine is diatomic, and on the periodic table in the classroom, it is blue. The lettering is blue, which indicates that it is a liquid. Iodine is also diatomic, and if you look at the periodic table in the classroom, it is black, which indicates that it is a solid. Mercury, Hg, it is not diatomic, so we do not need a 2. But if you look at the periodic table in the classroom, you notice that it is blue, which indicates liquid. Nitric acid, the formula for nitric acid is HNO3, and we said that acids were always AQ. Carbon dioxide, CO2, G for gas. Now the other part of that target is I can use the solubility rules to determine if a compound is soluble in water. You were given a handout in class, and if you weren't in class, page 170 in your book has a handout that looks like, well, I'll show you in a second. Most ionic compounds dissolve in water because water is very polar. What that means is that the water molecule, the hydrogens have a slight positive charge, the oxygen has a slight negative charge. Therefore, since ionic compounds are made of positive and negative charges, when you drop an ionic compound in water, the water molecules surround the positive end, their positive end, around a negative ion, and other water molecules surround their negative end around a positive ion, and they pull it apart slowly. And that all happens because of the polarity of water. Here's an animation that shows exactly what I'm talking about. Just give it 1 second to load. Start movie. As you see, salt is being added to water. Water acts as a solvent, which means that certain molecules can dissolve in it, or ionic compounds. Now it will blow this up, and you can see the positive oxygen end, or the negative oxygen end, combines with a positive. The positive hydrogen end combines with a chlorine. And that just continues until the whole ionic compound is torn apart. And then, to keep these from going back together, the water molecules just surround each ion with what's called a hydration shell. And that keeps them from recombining until the water molecules slowly evaporate, and when there aren't enough water molecules to keep these from reconstituting, then they will. So this happens because water is polar. When ionic compounds dissolve in water, they're called electrolytes because they cause water to be able to conduct electricity. pure water will not conduct electricity. But if you put a little bit of salt in the water, then there'll be free ions present that can move and cause or generate the current. So electrolytes are ionic compounds that dissolve in water. Solubility. If something is soluble, that simply means it will dissolve in water. You put it in water and the solid disappears. If it's insoluble, it does not dissolve in water. You'll see the term slightly soluble on some charts, solubility charts. Slightly soluble just means insoluble, basically. It means that there is a very small amount that will dissolve, but it's an undetectable amount. So only a tiny amount, that's really saying that it's insoluble. And you can tell that it's insoluble if you add a little bit to a small amount of water and it just turns the water cloudy. That's an indication that it's insoluble. How do you tell if an ionic compound will dissolve in water? We will use the solubility rules on page 170. Here is the handout that's in your book. You can use this one. I've given you this handout, or you can use this one, which is the one I prefer. I've written in that this is mercury 1 just in case you don't notice that Hg2 plus 2 is mercury 1. Notice with this chart, you can use either chart that you like, but this chart, it gives you the negative ion first, so always look at the negative ion to see if it's soluble. Any negative ion with an alkali metal is soluble. Any negative ion with ammonium ion is also soluble. Chloride, bromide, or iodide ions will be insoluble if they are with silver, lead, mercury 1, or copper 1. Any other positive ion, they will be soluble. You just need to spend a little time looking at the solubility chart to learn how to read it. It just takes a little practice. Let's do a couple of examples. Barium nitrate. I'm going to look at nitrate because nitrate's a negative ion. Let's go back to the solubility chart and find nitrate. Let's see, scroll down here. Nitrate. It says that any positive ion is soluble with nitrate. So nitrates are soluble. So barium nitrate we would expect to be soluble. Potassium carbonate. We'll go to the chart and look for carbonate. Potassium is a group 1 metal, therefore it is an alkali metal. So let's go back to the chart. It says that alkali metal ions with any negative ion are soluble. Therefore, potassium carbonate is soluble. Sodium sulfate. Sodium is a group 1 metal, therefore it's soluble. Sulfates are also soluble if you go back and look at the chart. Sulfate, insoluble with these ions. Any other positive ion, it would be soluble. But alkali metal ions are soluble, so that compound will be soluble. Copper hydroxide, copper 2 hydroxide. Let's look for hydroxides first, and remember it's with copper. Hydroxides, alkali ions or ammonium would be soluble. Anything else would be insoluble. And it is not combined with ammonium or an alkali metal, so therefore copper 2 hydroxide is insoluble. Mercury 1 chloride. What did it say about mercury 1? Mercury 1 is here. It says that mercury 1 is insoluble with chlorides. Mercury 1 chloride, insoluble. Ammonium phosphate. We'll look at phosphates, and in particular if they're combined with ammonium. Phosphates, it says alkaline ions or ammonium are soluble. We had ammonium phosphate, so it's going to be soluble. Chromium 3 sulfide. Let's look and see what it says about sulfides, and remember it's with chromium 3. Sulfide, if it's with ammonium it's soluble. Any of these ions it's soluble. Any other positive ion insoluble. Ammonium, wait, what was it? It was chromium. So chromium is not listed, therefore it's insoluble. Lead 2 sulfate. Let's see what it says about sulfates. sulfates with lead 2 is insoluble, therefore insoluble.